I want you to turn to page 40 in your ISN and find this outline that we've done already. And so far with our congruent triangle proofs, we've said if two parts are congruent, then we can say either vertical angles or reflexive property. That will give us our third congruent piece. And once we have three congruent pieces, then we can say that the triangles are congruent because of one of these 5 reasons. Well, now we're going to learn how to do what I call level 2 proofs, and that's using CPCTC. So to start, once we know triangles are congruent, and you don't have to write this part down, but just pay attention to what I'm saying. If I know these two triangles are congruent, that means this side's congruent to that side, these two sides are congruent to those two sides, that side's congruent to that side, these angles are congruent, those angles are congruent, and then these angles are congruent. So what I've done is said, if we're using side angle side or side 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 or whatever reason, and we say these two triangles are congruent, then we know all their other corresponding parts have to be congruent. So that's what we're going to use now. So let's fill out the outline, and then I'm going to tell you what everything means. So if we know the triangles are congruent, that means other parts are congruent. So we can get even more congruent parts. And the reason we know other parts are congruent is this acronym CPCTC. And that stands for corresponding, that's where the C comes from, parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. So if two triangles are congruent, then all of their corresponding pieces are the same. Okay? Now, don't worry about stressing it. All you have to about stressing about knowing how to remember this. All you do is put 3 C's, C, 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 put a P there and a T there. CPCTC. Corresponding parts of congruent triangles are congruent. And then once we know that the parts are congruent, then we can go and give a vocab word like therefore these are midpoints, or therefore this is a midpoint, or therefore this bisects something. So we can use some of our vocabulary. So let's go ahead to make sense out of this, and let's do an example. So go to the next page in your ISN and hit pause if you need to. And we are going to be given that segment AB is parallel to segment DC. And that M is the midpoint of AD. We're going to have this picture. Okay, and I want you to prove that M is the midpoint of BC. Okay, hit pause if you need to catch up on drawing the picture. So we know that AB is parallel to DC, and we know M is the midpoint of segment AD. What we're trying to prove is that M is also the midpoint of segment BC. So notice that this time we don't have anything here about triangles being congruent. We're going to say that part within our proof, but that's not our end goal. So this time we're not stopping at triangles being congruent. We're going to stop at saying M is the midpoint of BC. So we're going to follow our proof outline like normal. We're going to start with our given information. So we know AB is parallel to DC because it's given. And from that, we are going to look for congruent parts. Now, if you remember, when you know lines are parallel, you're supposed to look for a Z. So when I know AB is parallel to DC, I'm going to find a Z. You can choose this Z or that C. It doesn't matter which one you want. You might end up with angle, angle, side at the end instead of angle, side, angle. But if you want me to check to see if you're right, just bring it up to me after you finish. But I'm going to pick this C right here, and I'm going to pick this angle and that angle. So I'm going to call those 1 and 2. So if lines are parallel, then that means 1 and 2 are congruent because they are alternate interior angles. So our congruent part is that angle 1 is congruent to angle 2 because they're alternate interior angles. So we have a given and a congruent part. Step 3, use your second given. Our second given is that M is the midpoint of AD. And the reason I know this is because it is given. Okay? And now from there, I'm going to get a congruent part. And again, if you remember the trick I taught you, we have a vocab right here. So what does that mean our next reason is going to be? The definition of that vocabulary word. So what does it mean for M to be a midpoint? Well, if M is the midpoint of AD, that means M is in the middle. So that means this section AM is the same as this section DM. So these two segments are congruent. So that's going to be my congruent piece, is that segment MA is congruent to segment MD. And I know that because that's the definition of midpoint. So see, every time you have a vocab word, you're going to have a definition of that vocab word next. Okay? So now I've got my two congruent parts. And once I have two congruent parts, that means I'm going to look at my picture. And my picture is either going to show me vertical angles or reflexive property. So when I look at this picture, I do not have anything glued together, but I do have this X right here. And the X shows me vertical angles. So I've got this angle is congruent to that angle. I'm going to call this angle 3 and 4. So statement 5, angle 3 is congruent to angle 4 because they're vertical angles. Okay. Number 6, once you have 3 congruent parts, 1, 2, 3, now you go to the part where you say the triangles are congruent. So now I've got enough marked that I can say triangle ABM is congruent to triangle DCM. Now I need to look at why. Well, I've got these two angles and that side marked, so that is angle, angle, side, or side, angle, angle. Doesn't matter which way you write it. And this is where we've stopped from here. Okay, we've gotten all the way down to this part. This is where we'd stop. Well, now our next two pieces come in. We are not just trying to prove that these triangles are congruent. We're trying to prove that M is the midpoint. So because all these triangles are congruent, or because these two triangles are congruent, that means all of their congruent corresponding pieces are congruent. So if this triangle is congruent to that triangle, that means BM is congruent to CM, because these are corresponding sides. If you see right here how we wrote it, we have BM in the same place as we have CM. So BM is corresponding to CM. So statement 7, we can say BM is congruent to CM. And the reason they're congruent, the reason we know that BM has to be the same as CM is because corresponding parts of congruent triangles are congruent. So if the triangles are congruent, all of their corresponding pieces are congruent. So we're not going to write out that big sentence. We're just going to acronym CPCTC. So these segments are congruent because of CPCTC. Statement 8, if these two segments are congruent, if BM is congruent to CM, that means M has to be the midpoint. So that's our last statement right there. This is what we're trying to prove. And this is going to come down and be our last statement. So M is the midpoint of BC. And we know that because since it's the midpoint, That's what it means to be a midpoint. Definition of midpoint. Since these two segments are congruent, that means M is in the middle, so that's the definition of midpoint. So this is what a longer proof is like using CPCTC. So now there's another packet in your, or a worksheet that you need to do that was not in your original packet. So come and see me right now and you can get the next worksheet, and then after you complete that, check out the answer key to see if you did it right.